Hi everybody. Today whatever day you actually plan on looking at this video, if you actually plan on looking at this video, this is just kind of an extra example set of 4.8 problems. So real world problems. I'm not going to be writing the problems out, but I am going to be doing problems from the textbook, so I'll give you numbers with the ones that I plan on doing. All right, so blank slate for us here. First problem, I'm just going to go ahead and actually, before I start problem, I want to tell you a couple things that might have been lacking from some of the previous lessons. And the first thing is, oops, sorry about that. Got to actually get my pen here. First thing is angle of elevation, angle of depression. There are two very important things to know what they are, and it may have been, I know we used elevation once and it's kind of talked about a little bit. Angle of elevation is measured from the horizontal. So whatever horizontal, so like from eyesight or something like that, and looking up. So we gave an example of eyesight looking up to the top of a tree, and we could figure out the height of that tree using an angle of elevation. And you got to know that that distance there was an extra 5 foot 8 inches. Okay, that was from the example we were talking about. Whereas angle of depression is still from horizontal, only in this case it's looking downward, and this would be my angle of depression. So this would be my theta here, this would be my theta here. Represent angle of elevation and angle of depression. All right, so angle of elevation would be kind of like standing at the ground and looking up at something, whereas angle of depression would be standing on top of something and looking down. There's different areas where this is going to get used, and you'll see them in these examples that we are working on for 4.8. All right, so the very first problem, they're actually going to use this. So we're going to go ahead. I'm just going to start with question number 1. And question number 1 is finding the height of a cathedral. And it gives you, now I know it gives you pictures, but you should be able to draw these things without pictures as well. So it says well, here's the thing. First of all, you should basically be drawing yourself some triangles, but you need to know what you're drawing beforehand. So kind of read the problem first before you draw any pictures. So the angle of elevation of the top of the cathedral from a point 300 feet away, the angle of elevation, if you read through that, says is 60 degrees from level ground. And I want to find the height of the cathedral. So you're standing on level ground. You're kind of here. And we are actually measuring the elevation from the ground, not the person's eyesight in this particular case. And the angle of elevation is 60 degrees. Now we assume that the cathedral stands at a 90-degree angle, nothing fancy here. So it tells me that this is 60 and this is 300 feet away, and here's our cathedral. Now, some of these are not going to require any inverse trig because here we have an angle and we're not solving for an angle here. So we've solved this kind of problem before. We look at this angle, we look at the two sides we're given, so we know that tangent of 60 is equal to opposite over adjacent. And tangent of 60 degrees is, I hope you can do this in your head or using your finger trick, is the square root of 3 equals x over 300. And if you solve for x, x is 300 root 3, which is approximately equal to, if you plug in your calculator, 519.62 what? You got to pay attention to the question so you know your units. In this case, we're talking about 300 feet away, so we had to have feet in our answers. Okay, so a lot of these problems are not going to be too challenging. Not too challenging here. So let's go on and let's look at number 2 here. Or sorry, not number 2, because that's actually one of your assignment problems. So let's go ahead and look at number 3. Finding the angle, so using the angle of depression. So we have some lighthouse out here, and from the horizontal, it measures an angle of depression that is 10 degrees. And the height of my lighthouse is 120 feet. And you want to figure out how far away the boat is from the shore. Or sorry, not boat, buoy. I guess it'd be helpful if I read the problem right. All right, so here's the thing. We can use the straight up 10 degrees, or we can figure out what the angle is inside the triangle. And it's up to you. One way we can think about this is if we had the triangle out here, this 120 is actually the 120 out here, and this x is actually up here as well. The other way to think about this, it depends on what problem you want to do. Do you want to do the 10 with the 120 and the x this way, or do you want to use the angle 80 degrees? Because this is a right angle here. Because this is vertical to horizontal, has to be a right angle. It's up to you. Doesn't matter to me. It won't break my heart if you use one way over the other. So if I do a little bit of erasing here, so I don't actually want to use the outside triangle. I want to use the inside triangle. So I can say, according to this 80 degrees, I know that the tangent of 80 degrees is equal to x over 120, and therefore 120 times the tangent of 80 is equal to x. Make sure your calculator's in degree mode when you do these problems, because most of this stuff in the real world, kind of these type of problems, are in degrees, not radians. And you should get x is equal to 680.55 feet. So these first few problems are pretty straightforward, I believe. There are a few words here and there that you might not understand, like a guy wire. A guy wire, if I do a little bit of erasing here, I always called them guide wires, but they're actually guy wires. If you have some sort of an antenna, and you can actually see this from my classroom, and I'll show you what I mean by it. If you have some really tall antenna, and you have some stuff going on up here, let's say that's a satellite of some sort. Guy wires are the wires that come off the side that keep it stable. And the one you can see from my room actually has this set of guy wires. I believe it has a set of guy wires down here, and a set of guy wires there, and guy wire here, and guy wire here. I always called them guide wires, like I said, because I didn't know that's actually how they were spelt. Because I just figured it kind of guided it, made it sure it didn't topple over, basically. The taller these skinny things are, the more guy wires you need. All right, but you'll notice that these guy wires create triangles at a right angle. So there's all sorts of stuff you can do that with the trig here. Okay, let's look for a harder problem. Let's see if we can do 14. You're hiking on a level path towards Colorado's Front Range. Some guy determines that the angle of elevation to the top of Long's Peak is 30 degrees. Moving 1,000 feet closer to the mountain, he determines the angle of elevation to be 35. How much higher is the top of Long's Peak than Otis's elevation? This one is challenging. This one's going to kind of hurt us a little bit. All right, so here we go. You're walking along a flat ground, and you come across this peak. Long's Peak. So this is Long's Peak. And this is the acme, the top of Long's Peak. And you're standing over here and you measure this angle of elevation to be 30 degrees. You then move 1,000, right? 1,000 feet closer. And you do the same thing. Beauty of colors, I can change the colors here. You do the same thing, only now, since you're closer, the angle of elevation is different, so it's actually 35. And we want to figure out what is the height of Long's Peak. This one's going to be hard. So here's what we want to do. I think we kind of need this little distance between the peak and where you're standing. So as long as I do this correctly, because I forgot to do this one before I started. So let's think about the 30-degree angle. If we think about this entire length is y plus 1,000. And this little length is just y. All right, so I have the red triangle is tangent of 30 equals to x over y plus 1,000. But I also have, which I should have done in red on that one, but oh well. I also have the tangent of 35 is equal to y over, sorry, not y over, goofball, x over y. All right, so now some of you are probably going, what? Well, I don't even know where to go from here. Now, let's look at this left-hand one. This left-hand one is going to be very important for us. You notice that I have two variables. Well, I don't like two variables. I like to have equations with only one variable so I can solve for that one variable. So let's do that. I have a second equation that has a comparison of these two variables. So I can say, if I multiplied by y and divided by tangent, I would get y is equal to x over tangent 35, which you could actually rewrite as x cotangent 35. Might be helpful here. Which then I can replace or substitute into this y. Now remember I told you this was going to be a hard problem. All right, so I get tangent of 30 is equal to x over x cotangent 35 plus 1,000. Now we need to solve for x. Darn. This is starting to look uglier and uglier. But most of you, I think, could probably solve this one. I like this number 14, by the way, because it is more intense. It's more intensive to do. So I have to cross multiply. So cross multiplication here is really not bad as long as you just kind of pace yourself. 1 times x is x equals tangent of 30 times x cotangent 35 plus 1,000. If you distribute that tangent through, you get x tangent 30 cotangent 35 plus 1,000 tangent 30. And some of you have probably glazed your eyes over and you might have lost me by now. But just kind of bear with me here. So here I need to solve for x, so I need to get x's together. So I get x minus x tangent 30 cotangent 35 equals to 1,000 tangent 30. And here, since I have x's together, I can factor that x out. And now I have x times a number. You guys, I hope you've been paying attention here. Tangent of 30 is just a number. Cotangent of 35 is just a number. That means I have x times a number. And I can say, okay, well, that means x is 1,000 times the tangent of 30 over 1 minus tangent 30 cotangent 35. And this would just be a plug into your calculator to find an estimate. Now I have my answer key, so hopefully I get the right answer here. Their answer key looks a little bit different than mine, so I hope I did the right thing. Oh, I think I did. Theirs just looks different. So let's go 1,000 times the tangent of 30 divided by 1 minus tangent 35 times 1 divided by tangent of 30. Oh, got to make sure we're closing our parentheses in all the right spots. And I get negative 271, which is not correct. So I think I entered it incorrectly. So give me a second here. I'll retry my calculations. I'll actually make my fraction 1,000 tangent 30. 1 minus tangent of 30 over tangent of 35. Oh, whoops. Yeah, so 3,000. I just forgot a 0. So I get 3,000. Where's my pen here? 3,290.5 feet high. Oops. I don't want yellow. Oh, that was a hard problem. To jump from those last two problems that we did to this problem, that's quite the stretch. But remember, I skipped about 10 problems to get here. Let's go ahead and try one more. Let's go ahead and try number 18. Come on here. All right, let's try number 18. And then I'll say adieu. So 18 says, navigation travels at a speed of 40 knots from Fort Lauderdale on a course of 65 degrees for 2 hours and changes course of 155 degrees for 4 hours. Determine the distance and the bearing from Fort Lauderdale to the boat. Oh, holy cow. How are we going to do that? So you have some sort of point here. Here is Fort Lauderdale, Florida. So here we go. It's traveling at an angle of 65 degrees for 2 hours at 40 knots. Which means this is 80 nautical miles. Then it changes to 155 degrees. Well, from horizontal, it needs to change to 155 degrees. So if I go 155, I have to go 155, which is this over here. So now I'm traveling this direction. Man, this one's a hard problem, huh? All right, so 155, and it travels for 4 hours at the same speed, so that's 160 nautical miles. Well, then the question is, how far is it from the original Fort Lauderdale? It's kind of a tough question because some of you might not see that this is actually a right triangle. Now what you can think about is, if this was 65, let's go ahead and do a different color here. If this was 65, this angle was 115? Because they have to add up to 180. Remember, parallel lines cut by transversals? Remember? All right, if this is 115, this is 155. That's 270, which means this had to be a 90-degree angle. Because if that's 270, the leftover is 90 degrees. Well, that means this is now pretty easily solved. This one actually doesn't even require any trigonometry. Oh, it does, because it actually asks for bearing, so my fault. I'm asking for the distance, but I have two sides, so I can do Pythagorean theorem pretty easy. So x is equal to the square root of 80 squared plus 160 squared. Easy calculation on your calculator there. And if we do that real quick, 80 squared plus 160 squared is 178.8, let's go 885 nautical miles. And I want to figure out bearing. So I need to figure out this angle here that I could add to 65 to figure out my bearing. Now I know I measured my bearing from the wrong direction because I wasn't thinking, but everything should still come out the same here. So that's 65. I need to figure out this little green arrow here. So I'm going to use the given values that I have, 80 and 160. So I'm going to use tangent. Tangent of my green arrow, which is theta, is equal to 160 over 80. Well, that's nice because I can simplify that before I do anything. Here is some inverse trig, finally, because I need to figure out an angle. Oops, not 2. Theta is equal to tan inverse of 2, because I can't do this one in my head. So tan inverse of 2, I get theta is equal to 63.435 degrees, because I'm in degrees. So my bearing should be, I'm going to check my answer key here, but my bearing should be that number plus 65. So I get a bearing of 128.435 degrees. Let's go ahead and do a quick double check. If I'm wrong, I'll have to fix it, but let's see, number 18 for this one, 128.435, measuring 178.885 nautical miles. Looky there. All right, so I know I only did 4 examples, but I think it's kind of plenty. I tried to do each different type of problem. Notice one that required some inverse trig, one that required some proportions and that sort of idea. All right, so good luck on this. I know it's not for a couple days, but most of you, or actually some of you, if you actually are willing, can actually get ahead. This stuff is, I love this stuff, this real world stuff, because then you really actually see where in the world could trig be used. As much as you guys really don't like to admit it, it is used in the real life. All right, good luck, have fun. See you guys later.